So, yes, I'm going to talk a little bit today. I'm Dan O'Day with Unit 42 from Palo Alto Networks, and we're going to talk today a little bit about a bunch of cool stuff, but especially our partnership with AWS's security team. And I'm going to be allowing my colleagues to introduce themselves, both Margaret Kelly and Jen Paz from AWS. They'll be introducing themselves as they come on stage shortly. My background is military, federal law enforcement, and then been in consulting for a little over a decade now, doing incident response type work. So specifically doing digital forensics and incident response. That's what Margaret and I specialize in. And then you could think of us like cyber firefighters and arson investigators in some ways. And we're going to talk today about some case stories and some things that we've seen in AWS and about the partnership that we have with AWS and how we can help customers with those things. So this is just a high-level overview of a little bit about what we're going to be discussing. I'll briefly introduce us and we'll talk about the partnership. Then we're going to share some war stories and just kind of walk through some things we see, talk about some of the most common tactics and trends that we're seeing in incidents in AWS right now. And then we'll talk through some recommendations related to that. And then we're going to have a panel discussion with both Palo Alto Networks and AWS, kind of answering questions related to that. So initially, Palo Alto Networks, if you're not familiar with us, we really want to be a cybersecurity partner of choice. And we have well over 85,000 customers. We're a global organization, a lot of different things. And Unit 42 specifically focuses on kind of threat intelligence and services, and that gets baked into Palo Alto Networks products. So we have both proactive services as well as managed services, like our managed detection and response, managed threat hunting, et cetera. And then our incident response services, which is where Margaret and I both specialize. And again, that's all with an underlying foundation of threat intelligence. And that threat intelligence piece, like I said, gets baked into the product. So even if you're not an explicit Unit 42 customer for using any Palo Alto Networks product, whether our next generation firewalls, whether our endpoint solutions, cloud solutions, then you're going to be benefiting from that threat intelligence because we make sure that we protect all our customers rapidly as soon as we get information. That is 24/7 we are enriching our products. Unit 42 publishes a lot of information, so you can learn more about the kinds of things that we're doing and talking about. The big one that's most recent is our Global Incident Response Report. We'll have a QR code later if you're interested in that, but there's a picture of that on the top left of this slide. We've also got our extortion ransomware report, cloud-specific reports, MITRE attack reports, where we talk about the most common techniques and actually what that looks like in attacks. We have a blog where we talk about stuff all the time, including lots of things involving AWS and incident response matters with AWS. And we're on Twitter, we're on LinkedIn, we have a bulletin. We also have a GitHub repository called Unit 42 Timely Threat Intelligence, where we just get stuff out, IOCs and stuff like that, really rapidly all the time. And so all that stuff's publicly available, and we share that widely. I'm going to invite my colleague, Margaret, to come up and talk a little bit more about our collaboration with AWS and start talking about some war stories.
Hi, everyone. My name is Margaret Kelly. I'm a principal consultant at Palo Alto Networks, Unit 42. And today I'm going to talk a little bit about the Unit 42 and AWS security collaboration. We have some big news. Palo Alto Networks was named Global Technology Partner of the Year, and some of the highlights of this is helping organizations go from their code to cloud to their security operations center. And as you can see on the screen, there are numerous distinctions with this award. The one that we are going to be talking about today is the Security Incident Responder Service Ready Partnership. Let's take a look at what this partnership looks like between AWS and Unit 42. Now, no one knows AWS better than AWS. And when you open a security incident with them, their SLA to respond is unparalleled. When you open a new case, an AWS incident responder will reach out to you within 15 minutes to start working with you to determine what your concern is and what might be going on in the environment. Now, when you combine that with the broad reach of Unit 42, who has the ability to incorporate other data sources outside of AWS, including on-prem and SaaS applications, into the investigation, while also performing as the incident command for their large investigations. You truly have a winning team to help you in your time of need. So before we get into these case studies, I wanted to talk a little bit more about how this partnership plays out in those case studies. So throughout an investigation, both teams will help you understand what's going on within the environment. So not only will we contain the threat, we will eradicate the threat actor as quickly as possible. And this is my favorite part. Along the way, we also provide recommendations and best practices so that you can better secure your environment. So now let's get into these case studies. So similarly to an investigation with a case study, we'll talk about what the threat actor did. And then after each of them, we will discuss the different recommendations and best practices associated with that case study. So for this first case, it originated from a notification around high billing with EC2 instances in a single AWS account. Upon further review, the organization identified multiple large EC2 instances, and as you can guess, they're being used for crypto mining. Breaking down the attack path here, it started with an exposed access key. Access keys get exposed in numerous different ways, and they can get exposed in internal and external code repositories, as well as being exposed on publicly accessible hosts, as well as sometimes they have to be in environment variable files, but then those environment variable files are made publicly accessible, so then those credentials are also leaked. After the threat actor gained initial access to the AWS account, they proceeded to do something that's actually pretty abnormal. They deleted the Cloud Trail logging that this client had enabled. This is abnormal because, as we all know, Cloud Trail logging is enabled by default for 90 days and is accessible via the API. So there really wasn't a lot of point of doing it because their attack was pretty noisy already. So they disabled this logging, and immediately a guard duty alert went off to also notify the organization of this abnormal activity. Following this, they created a new identity and access management user and used that to then create these ginormous EC2 instances that they used for crypto mining. So looking at some of the remediation and best practices, there are so many that apply to all of these scenarios. So we're going to talk about the first one, which is using IAM roles and making sure you follow credential management best practices. Access keys are long-term credentials and they don't expire, which is why it's absolutely recommended that you use roles instead, because those are temporary credentials. Now, some applications you have to use long-term access keys and you can't get around that, but you want to make sure you are following credential management best practices and not leaving them publicly accessible to anyone on the internet. For this next case study, it's a little more complex and it has a couple of different components to it. It was a large-scale extortion operation that impacted multiple environments because of leaked environment variable files. Within these leaked environment variable files, there were thousands of credentials that were exposed. Here we have a play-by-play of the attack. It starts with this publicly accessible environment variable file. Now, some applications still require environment variable files, but they don't require them to be publicly accessible. So in this case, this environment variable file was publicly accessible, and unfortunately, it did contain an access key and secret. The threat actor obtained this access key and secret and pivoted right into the AWS environment. They performed a couple of different discovery calls, specifically against identity and access management, as well as S3. Following this, they created a new IAM user, and then this is where it gets interesting. they created multiple Lambda functions in every single enabled region. Now, these Lambda functions weren't unique. They were the same Lambda function in every single region. Now, to wrap up the attack, they had two pieces left. First one, they used those Lambda functions, and they scanned a list of domains on the internet, and surprise, surprise, they looked for publicly accessible environment variable files. Following this, they exfiltrated the data from this organization's S3 buckets and proceeded to extort the victim. Taking a step back, this is what this threat actor infrastructure looks like at a higher level, and it's actually a very cyclical attack. So starting at number 1 for AWS account A, you have a threat actor compromising the access key and secret, logging into that account, and proceeding to create these Lambda functions. The Lambda functions then scanned the internet for publicly accessible environment variable files, but then instead of putting them in AWS account A, they actually put them in AWS account B. AWS account B contained a publicly accessible and writable S3 bucket. So that's where the threat actor uploaded the environment variable files. They then proceeded to look at these environment variable files and pull out the credentials that they wanted to use. In this case, it was an access key and secret. Then we have AWS account C, where they did the same thing. And so this whole attack happens over and over again. Looking at this case in the context of other cloud cases that we handle, you can really see that these attacks are happening with alarming speed, precision, and scale. These threat actors have cloud expertise, and they're constantly taking advantage of poorly configured environments. And they're knowledgeable about cloud services. They were able to spin up these Lambda functions exceptionally fast. And when you're looking at the speed of the attacks, yes, these Lambda functions, they had them already created. They had the script set up. But in other attacks, threat actors are using infrastructure as code as well as scripts to create their attack infrastructure. And so the speed of the attacks continue to happen faster and faster. And finally, when you look at the scale of impact, it's pretty massive. In this case alone, it impacted over 110,000 unique domains. And looking at what was gathered, there was over 90,000 unique environment variable files gathered. And of those 90,000, 7,000 of them were associated with cloud services as well as SaaS applications. Looking at all of these credentials gathered, we grouped them into a couple of different categories. Application, database, and email are the highest. That's not overly surprising. But what is interesting is the high number of cloud credentials. And this really shows the shift that we are continuing to see of organizations moving to the cloud and using SaaS applications. And so this also shows the shift in the threat actor landscape to have the threat actors continue to attack cloud environments. So for some remediation and best practices, again, there's a couple that we could go through, but I'm going to focus on using infrastructure as code as organizations. Using infrastructure as code really helps to have consistent and very secure deployments. And then when you're trying to monitor for abnormal activity, your in-house deployments will be very consistent. It'll follow a very similar pattern within the CloudTrail logs. So if you have a threat actor or a rogue employee trying to spin up resources, it's very detectable in the CloudTrail logs if they don't follow the same infrastructure as code pattern. Now, for a final case study, this one revolves around the threat actor group JavaGhost, and they have impacted multiple industries. Taking a look at their history, they have been active for over 5 years. And they historically focused on website defacement, but now they've shifted to sending out phishing emails. Let's take a deeper look at one of these attacks. So this is what the Java Ghost attack path looks like. Again, it starts with an exposed access key. And then after that, they gain initial access to the AWS account. I call out specifically, though, that they gain CLI access to this AWS account because access keys give CLI access. But this threat actor was not content with CLI access. They wanted console access and to be able to visually see what's in this account. And so instead of attaching a login profile to this user that they had already compromised, they tried to be nefarious and hide. And so they performed two different API calls. They first performed get federation token, and with the results of that API call, they proceeded to perform the call get sign in token, which returned an authenticated URL from the base access key credentials. Now, with that URL, the threat actor now has console access to this AWS account without attaching a login profile. After this, the threat actor group does something else that's interesting. In the other two cases, we saw them create new IAM users. They didn't do that in this case. They create new IAM roles and attach a trust policy. So what this trust policy does is it grants a different external AWS account access to this specific role. So now the threat actor has another way into this AWS account for persistence. One of the reasons they choose to create a role versus create a user is people tend to forget that you can just come in through a role. And so when you're trying to clean up threat actor created resources, sometimes this gets missed. So finally, the threat actor creates their phishing infrastructure. So if an organization is already using the simple email service and workmail, they'll use the pre-existing infrastructure and send out their phishing emails. If an organization isn't using SES or workmail, they will set up the infrastructure themselves, then send out all of these phishing emails. Java Ghost performs a couple of additional operations that I find really interesting. The first one here is creating a new security group. The name of the security group is not surprising. It's Java Ghost. And the description is the group's slogan, "We are there, but not visible." Now, with this security group, there's no rules attached. So there's no rules allowing inbound or outbound traffic, and these security groups aren't attached to any EC2 instances. They purely create the security group to note that they have been in this account. The other interesting thing that they do is create new IAM users and access keys. These new users have unique names and also names that they try to blend into other existing users. And with these access keys, yes, they're being attached to these new users that they're creating, but they're also getting attached to pre-existing users in the hopes that, again, during the remediation process, they will get missed. And finally, they do attempt to enable disabled regions, and they do this in the hopes that they can spin up their phishing infrastructure within an unmonitored region. So taking a look at the remediation and best practices, the one I want to focus on today is using service control policies to prevent unused services. Within your AWS environment, you will have a ton of accounts. You might even have hundreds of them. But each account will probably have unique workloads that don't need every single service available. And so by using SCPs to lock down those unused services, you can better manage what can or cannot be done in that specific AWS account. And so then Java Ghost can't come in and spin up those phishing emails in one of your accounts. Now we're going to pivot and look at some of the high-level tactics and trends that we see within our cloud attacks. So here are the top 5 that we like to talk about, but today we're going to focus on exfiltration and impact. Exfiltration is still a common issue that we see time and time again, and this is all because of overly permissive credentials. And so what threat actors do is they get into an environment and they're able to do whatever they need to do. And then on top of it, they exfiltrate data. And they're exfiltrating data from S3, EC2, and RDS. And not only are they exfiltrating the data, they again have the permissions to delete the data. So they delete the objects, they delete the buckets, they delete the EC2 instances and the snapshots, and they delete the RDS databases and the database snapshots. Looking at some of the notable TTPs, I wanted to look at how IAM is used for persistence. You saw in a couple of the case studies, threat actors really like to use it in a variety of different ways. They like to create new IAM users. Some threat actors take the time to see what existing IAM users are in there and try to match the names of those. Other ones don't care. They create blatant, obvious IAM users that stand out. And then threat actors are absolutely using trust policies to grant external access to the account through those roles. And finally, they're also deleting and creating access keys. So with the creation of access keys I talked about earlier, that they get attached to new and existing users. On top of that, if a user already exists and it has an access key attached, but the access key has not been used for days, months, and sometimes years, what the threat actor will do is delete the access key, because clearly it's not being used, so no one's going to know when it goes away, and they create a new one to, again, enable persistence. Now I'm going to pass it back to Dan to talk about some more recommendations.
All right. So Margaret's covered a lot of awesome trends, a lot of the things, and shared actual stories about how we see these. And these stories were chosen as representative examples because we see a lot of variations on a theme when looking at these sorts of things. So some of these things, we say they're the basics, but we all forget to do them. And so it's good to get reminders. The first is to really log everything everywhere, and that means even in regions that you're not using, because threat actors love to spin up stuff in regions that you're not using because they're thinking you won't look, right? So making sure that you've got logging there, making sure you've got VPC flow logs enabled, S3 server access logging. A lot of times we don't see that, and especially if you have any kind of regulated information in S3 objects. So I'm talking about personally identifiable information, protected health information, things like that. Anything that could trigger a data breach and legal obligations for you if it were to be exposed. This is really important, and the reason why is a lot of times S3 server access logging is not enabled by default, and then you're left looking just at bandwidth outbound from a specific bucket, and you don't know which specific objects might have been exfiltrated. And if you don't know that, then a lot of times from a legal perspective, you might have to make the assumption that the entire bucket's been exfiltrated. Because even though you may know it's not the full volume of data, with however you figured that out, you don't know which explicit objects had been exfiltrated, and so now you've got to make an assumption, and that can result in a much larger data breach notification than if you had access logging. Now you know exactly which objects have been interacted with, and you can narrow down the scope of notifications from a legal perspective. Further, making sure you have a strong identity foundation. Margaret's already talked about that quite a bit, so I won't go much over, but of course using short-lived credentials where you can, applying the principle of least privilege, etc. Knowing who's responsible and accountable for resources, especially large environments, we get it, you have lots and lots of accounts, things like that. It's very easy sometimes where we find something is happening in an environment, like, can we isolate this? Can we shut this down? And a lot of organizations aren't even sure. They're like, oh, we don't know what team is using this particular EC2 instance. We're not really quite sure how these Lambda functions fit into our larger operations, whatever. And then there's uncertainty about what you can do when you're trying to contain and remediate an incident. And that lag of time can enable the threat actor to further its impact. So this is what tags are for in AWS and other documentation that your organization uses whether you've got existing tooling for asset inventory and configuration management and such. And then, of course, limiting external exposure. If it doesn't need to be on the internet, don't put it on the internet. I know Margaret already talked about implementing SCPs, so leave that there, but obviously that great tool for permission management. Minimizing exposure rate. You want to basically manage vulnerabilities. Make sure you know where those vulnerabilities are. This applies whether you're on-prem or in the cloud, of course, but making sure you're aware of those things in that shared responsibility model and taking responsibility for the items that fall on you to manage those things, especially if it's internet-facing. You should be patching those things immediately as fast as you can because obviously they're going to be targeted in automated fashions, sometimes within minutes or hours of those vulnerabilities having proof of concepts made available online. Be sure to monitor for abnormal stuff, right? This is where Guard Duty and Palo Alto Networks products can help out a lot, is monitoring for those abnormal things. And then, of course, using cloud guardrails, so permission boundaries, to avoid common missteps. This can go a long way in preventing things from getting far too out of hand, even if there's an initial intrusion. Furthermore, Unit 42 can assist your organization with this. We do cloud security assessments, and that's something where we can come in and look at your environment, identify potential issues before it gets to the point where those are used against you by a threat actor, which hopefully never happens, of course, but help find the blind spots and things like that. So taking the guesswork out and getting some data to back up your posture. So that's been kind of the high-level part of our talk. We're actually going to be transitioning into a panel discussion shortly. Did want to just share a couple of resources really quickly, though. The first one is the Global Incident Response Report from 2025. We've got a QR code up there. I promise we won't rickroll you with these QR codes. But that one is going to give you lots of insights about IR reports, not just cloud, but also all sorts of things. It's a lot of data. So we've done like a lot of data science work to try to find the trends and talk about these things. A lot of great points for your leadership, especially if you're trying to get funding for different things and say, hey, look, these are the areas, these are the initial access vectors, how they're typically getting in. So one highlight, for example, from that report is phishing has often been an initial entry vector for many organizations. Last year, we actually saw software vulnerabilities take the lead as the #1 initial access vector, and phishing has retaken the lead again for 2025. So kind of an interesting trend to talk about. It still matters. Social engineering is still a thing. There's all sorts of ways that people are getting into organizations. And then the threat vector is a podcast that we have. And Margaret has been a featured guest on that podcast. Episode 49, I believe, is the dangers of cloud misconfigurations. This QR code is actually broken. Well, I don't know that it's actually broken, but the site has changed the URL since we published this, and so you won't get far with that. But if you go to Threat Vector Podcast, you can find it at a variety of outlets, CyberWire or on Palo Alto Networks site. Episode 49, you can hear more from Margaret talking about the dangers of cloud misconfigurations. And don't hesitate, if you have any issues, to get in touch with both AWS or Unit 42 or both of us, which we're going to talk about more in a minute. But here's a couple ways that you can contact Unit 42 24/7, 365. We also, again, have our research at unit42.paloaltonetworks.com, all those articles that we showed earlier and things of that nature. Those are some of the places you can do that. So now I'm going to invite both of my colleagues up, and I'm going to have Jen Paz give herself an introduction. She's from AWS, one of our colleagues, and we're going to shift into a panel discussion and talk through some more things and let you learn and hear both perspectives from Unit 42 and AWS. Jen.
Hello. Hi, my name is Jen Paz. I'm with the Customer Incident Response team here at AWS. I've been with AWS for about 6 years now, so it's been a great, amazing journey. I started off actually my career in audit and compliance. So just been a very interesting journey to get to where I'm at now. Essentially just want to be more hands-on keyboard. And so, yeah, I'm now with the Customer Incident Response team and love it.
Very cool. Jen, could you tell us a little bit about some of the unique capabilities of AWS Security IR and some of the unique capabilities that your team has?
Yes. So I don't know if you all have heard, we recently launched the Security Incident Response Service at reInvent in 2024. So I would say the features that I want to highlight of the service, well, first of all, we help customers detect and respond from security incidents. And the features that I want to highlight is the auto triaging, the auto containment, and TTC, which I will talk about in a little bit. So the auto triage essentially takes away that alert fatigue that security professionals feel, and it's a real thing. That's something that we've heard from customers is the alert fatigue. We want our security professionals to focus on what's really important, right? So we took that feedback and we said, okay, we will take that on as part of a feature for this service. So we do the auto triaging, and we will only present to you the incidents that actually really matter, that are true positives, and that you should focus your time on. So that's the auto triage portion of it. Then we have the auto containment portion. The auto containment portion does have a human in the loop element, so don't worry, we're not just gonna just press the big red button there, and that's only if for whatever reason you need to use that feature, it's available. And lastly, the TTC. I want to make sure I get this right. Threat Technique Catalog. TTC, we recently released that right before Reinforce. And essentially, it enriches post-incident reports that's part of the service with the techniques that were used by the threat actor. And it's AWS specific. And yeah, so that's one thing that I definitely wanted to highlight, the Security Incident Response Service.
Very cool. And I have to brag on the TTC for a minute because I just learned about it last night, actually.
Yeah.
And if you're familiar with the MITRE ATT&CK framework,
Yes,
it's like that tied to AWS, but more specific. Because, right, you're not going to see any mention of S3 in MITRE ATT&CK. But when you look at the TTC, it's going to give you that vocabulary, that incident vocabulary, both talking about the tactics and the techniques of these threat actors specific to AWS. And it's really awesome, both for AWS, but also for all of us to be able to have that vocabulary to talk about things in a unified way. And it gives you now things that you can use to tune detections, and they're all based on actual things seen in cases by AWS, if I'm correct on that.
absolutely, yep.
So really cool stuff. So one of the things I want to ask the panelists is, what are some of the most common things when folks are containing and trying to recover from incidents? What are some of the most common mistakes that you see customers make that can prolong recovery and prolong the time it takes to contain those incidents?
I'll take it. Okay. I would say not fully following all the breadcrumbs that are available. So I actually want to give an example that's closely tied to something that Margaret mentioned during her presentation. So let's say you have a compromised access key, and you are doing a log analysis, and you're like, okay, what did the threat actor do? What unauthorized resources did they spin up? What specific actions are they doing? You're doing your analysis, right? And you're going in and saying, okay, well, all of these resources were created by the unauthorized user. Let me go in and clean this up. And you notice in those API calls, you see something, get federation token. You see that API call in there, and you're like, well, let me focus on the mutative events. Let me clean that stuff up. And for whatever reason, you just overlook the get federation token. So, again, let's say you've cleaned up those resources, you've disabled that compromised access key, but you don't do anything about that get federation token. So that get federation token provides a session for the threat actor. So, okay, fine. They're like, okay, you want to, disable the access keys? I got another way, to keep doing my nefarious activities. And I believe that it could be the stress of dealing with the security incident, or maybe an education piece there, where overlooking that get federation token is so key. And having those AWS experts, having the customer incident response team, or just having a SME that really understands the ins and outs of the implications of these API calls is so important. And so I guess to tie that all up, to properly contain that specific scenario would be to apply an inline policy for that specific user that's using that session. There's now you don't actually have to manually put in that specific policy. You can it's actually in the console where you can revoke the session. But I would say that is just following the breadcrumbs and really truly understanding the implications, of those API calls, and what the impact could be, and yeah.
No, that was perfect. I would say on top of that, making sure, again, like what Jen said, following the API calls, because little things like modifying a security group rule, all of a sudden, your threat actor, if you allow SSH inbound from the internet, where initially that was locked down, one little rule change, and you're like, oh, this is like, one little thing, actually now allows inbound access to your AWS environment, that you want to make sure that you're really focusing on all the little pieces, because that one little thing that you missed truly can prolong the incident from, you might have it contained in a day to weeks and weeks and weeks, because they keep coming back in.
Very helpful. So what are some of the strategies and automation techniques that you see that can be most effective in accelerating detection and containment?
I'll start with this one. So making sure that your CloudShare logs are being centralized in one location, and that you are also reviewing them, and that you have set up alerts and detections based off of those CloudShare logs in a centralized location, that really helps to very quickly identify what might be going on within the environment. And when it comes to containment, practicing it. So you don't want to get to an actual incident and you've never practiced containment before. And containment takes place at all different levels. It takes place at the IAM level, and it also takes place at the actual resource level. So if an access key is exposed, do you know where the access key is located and how it's being used in your environment? Because if you don't know, and it's a business critical operation, and you want to contain it, your business isn't going to be really pleased when you lock down that access key and all of a sudden it has a massive negative business impact. So I would just say make sure to continue to practice the containment at all the different levels, because it's not just host-based anymore. It truly is identity, and there's just so many more components to it.
Yeah, I'll add to the other side of that, the respond and recover. So ensuring you have backups for your critical data is super important, and not just setting up that scheduled job, but actually going in and verifying that those backups are there, that it's actually backing up your data based on the schedule, like really going in and ensuring that that data is backed up, and just having those recovery strategies. Okay, X incident happened, now what? Do you have procedures? Do you know the right people to contact? Have you done tabletop exercises to practice this muscle memory? So yeah.
So how do you balance the need for rapid containment with that risk of disrupting critical workloads or losing forensic evidence when we're dealing with cloud-native incidents?
Yeah, sure. I'll take that one. So it all comes down to the business, right? All business requirements. And the customer incident response team, we will let you know, okay, these are the implications of doing X, Y, Z. So, for example, customer is, experiencing a security event, and say, again, they have compromised access keys. So in that specific case, there's options there, right? You can disable those access keys or you can delete those access keys. But let's talk about the implications. Let's talk about the impact that has, right? So explaining that to the customer is super important, and saying, okay, look, if we do disable, or let's say they want to go in and just delete the access keys, what other workloads are depending on that specific access key? Let's talk about that, right? So let's apply other mitigations. For example, we can go in and let's say the compromised principal has, star and has access to everything. Well, maybe let's start there. Let's say that those access keys actually are that there's workloads that are dependent on those access keys. All right, there's other mitigations that you can put in place. So just having that knowledge, that background is, I think, super important. And again, it all goes down to the business, their business requirements. Is it part of regulatory compliance requirements that they need to keep forensic data, all of that, right? So working backwards from those needs is how we will help the customer in whatever we can, and just really provide them the options, right? Like, okay, yeah, you want to go down this path, okay, these are the implications, and yeah, really understanding all of the what ifs.
And to add on top of that, to make your life easier to understand the business impact, use tags. Tags are phenomenal. So with your critical resources, tag them. So tag whatever the business unit is, tag the criticality. If it's critical data, tag that it's critical data. And then when you need to remediate and respond very quickly, hey, this is a super high critical application. We probably shouldn't, start deleting the access key and taking it all down. We need to make the more nuanced approach of fine-tuning it. And so that then helps you respond a lot quicker. So having the tags to understand the criticality as well as the contact, using your AWS environment gets so big, sometimes you don't know who owns this random super critical business application. And when it's 2 a.m. and you're trying to hunt someone down, good luck. So use those tags to kind of do everything that Jen was talking about.
And specific to, let's talk about EC2 instances just for a second. What are things, let's say there's an impacted, within the operating system on an EC2 instance, and we want to preserve forensic evidence from that. What are some of the unique abilities we have in AWS to preserve that information while still being able to rapidly recover that we might have a harder time with if we were on-prem?
Yeah, so there's a couple of things here. Before containing the EC2 instance, you want to obtain the memory. And if you haven't done this before, you absolutely want to test this ahead of time. So obviously try to gain the memory as quickly as possible, but then use the snapshot feature. So that is how you can quickly gather this information to then, do whatever you need to do to contain the threat to whatever the workload is. But use the snapshots to kind of get you what you need there.
From AWS's perspective specifically, what are some of the most critical security responsibilities that customers have to own to enable effective IR?
Yes, the lovely shared responsibility model is something that we really want to help educate customers with, right? The customer incident response team helps customers when they're having a specific security incident, and we're actually helping them with the security in the cloud, right? So we're walking through the security incident, the analysis, detection, all those pieces. It's really important to understand that and also depending on the service, the configurations, the encryption of the data, all of that does fall on the customer. And that's super important to No, and also just depending on the service, right? You can have EC2 versus S3. EC2, you need to set up the security groups, the permissions, the patching, all of that, right? With S3, you don't need to worry about patching S3 or anything like that, but you do have to worry about encrypting your data, setting bucket permissions, all of that. So understanding that, not just the shared responsibility model, but really understanding that per service is really important and super critical when it comes to dealing with security incidents, because that information is really important and something that I would say is super pivotal for a security incident.
And so when Unit 42 is called in initially on an AWS incident, what are some of the common initial states of preparedness or lack thereof that you observe in organizations?
So unfortunately, a lot of organizations still do not enable CloudTrail logs and store them in a centralized location. So thankfully, we can get them from the API, or else we'd be really blind. But normally, a lot of organizations don't have any logging enabled. And so when the conversation comes down to what data was exfiltrated, kind of like what we talked about earlier, unless those logs are enabled, you're not going to know. And so you can use some other services like the cost and usage reports to kind of get a feel of what might have gone in or out of the environment. But a lot of times you're blind to very critical pieces of information. So a lot of times logging is not enabled. A lot of times organizations don't know what's in their AWS account. So that also kind of makes it difficult when you're trying to figure out kind of what's normal or abnormal, because they don't know what's in there. So there's just a lot of training that can be done to really better secure these environments.
And for either of you or both of you, what foundational security measures do you often see being overlooked by customers?
It's going back to the basics. It's the least privilege principle, right? A lot of times, for example, if you're testing, this new feature, or you're implementing a POC, we see usually customers in sandbox environments just give it full admin privileges, and then when they go to actually, okay, we're going to use the POC in production. Did you go back and use the principle of least privilege? Did you ensure that only the permissions that are actually needed to complete X, Y thing is only applicable to that specific principle? So least privileged is definitely something that we're always talking about with customers, and there's ways to really understand what permissions your workloads need, right? You can within IAM, I believe it's like security credentials. There's in the IAM console, you can see the history of what permissions your work or your roles users used. So that is, I think, the most overlooked feature, because it's no longer legitimate to say, I don't know what permissions this specific workload needs, so I'm just going to give it everything. No, there's history, there's data that you can go back to see and say, actually, this is only the subset of permissions that are applicable, for this specific workload, and doing that iteratively, right? It's not just a set it and forget it kind of thing. So least privilege, that would be the answer for me.
So on top of that, the other thing, I would say resources don't need to be publicly accessible. That's still something that shocks me every time when we get in an environment and they're confused why, they locked everything down. They're like, these things should not be accessible anymore. And I'm like, well, there's public IPs associated with all of your EC2 instances. And they're like, oh, I thought it was required. Like, I thought my EC2 instances had to have these public IPs. And it's like, well, fun fact, they don't. And that absolutely, should not be the case. So that's also something that we commonly see. Similar to principle of least privilege, principle of don't make your resources public.
So we've talked about a number of different visibility gaps today. We've talked about obviously not having CloudTrail enabled. We've talked about not having CloudTrail in all regions. We've talked a bit about S3 server access logging. So in addition to those, or if there's anything further you want to expand on those, what are other common visibility gaps that you see that can hamper an investigation?
So one thing I'll start out with is VPC flow logs. So again, similar to S3, when you're trying to understand kind of what went in and out of the environment, if you don't have VPC flow logs enabled, and if you don't have any sort of third-party firewall in play, when it comes to the network level, you don't have a lot of visibility there. So VPC flow logs are one that I definitely add into the mix. Any more? Okay.
So finally, kind of in conclusion here, what's one key piece of advice that each of you would give to organizations who want to mature their incident response capabilities specific to their AWS workloads and environment?
Yeah, so this is one of my favorite questions, and I would say it's training. So taking the time to train your incident response team so that they have looked at the CloudTrail logs before, they've looked at the VPC flow logs, and also doing this through purple team exercises. So have some members of your organization, it could be your engineering team, that goes and spin up some rogue resources, kind of do a little, purple team exercise, hire AWS or Unit 42, we'll come in and do it for you. But that is something that I think is so beneficial for teams, not only, training on how to use AWS and use the logs, but proactively going in there and creating the scenario that would produce the logs that are very similar to what you would get in an investigation.
I'm going to take that from a more tactical perspective. So nearly 70% of the incidents that the customer incident response team receives are due to compromised credentials. So my advice would be, if possible, use something outside of long-lived credentials. Use roles, use federation for your workforce. Long-lived credentials, the customer incident response team, when we're with customers, we don't know where these access keys are stored. We don't know where the customer is storing these access keys. We don't have visibility into the GitHub repos that they're storing these access keys. So definitely, if possible, stay away from long-lived credentials and use roles, federation. That would definitely be number one advice there.
Well, thank you, everyone, for your time, for joining us today in this session. We hope it was productive and useful information for your organization. Thank you so much Jen for joining us, and we're looking forward to this partnership. And we've already been doing it. I shouldn't say looking forward. We've been doing it, but we're looking forward to continuing that partnership to further help you, right, and get in 15 minutes and kind of help out with the entire incident, whether in AWS or outside of AWS when they pivot, and helping secure your enterprise from code to cloud to SOC with Unit 42, Palo Alto Networks, and AWS working side by side to help you out. Thank you so much.
Thank you all.